Okay, we've got this pulley here raising a weight. How many inches will the weight rise if the pulley is rotated through an angle of 71 degrees 50 minutes? So the idea is that the weight is it's tied to the movement of the circumference of the pulley. So what we want to think about is if the pulley is rotated through an angle of 71 degrees 50 minutes, what does that correspond to in arc length? The distance of arc length traversed through this angle is going to be the distance the pulley or the weight moves. Okay, so what is 50 minutes in degrees? There's 60 minutes per degree, so 5/6 degrees. So you've got 71 and 5/6 degrees. So 71 times 6 plus 5, 431/6 degrees. That's the angle. Okay, now with arc length, radians are much easier to work with. So let's convert this to radians. You've got 180 degrees for every pi radians. So we'll divide this by 6 and divide this by 180 times pi. Okay, so this is about 1.254 radians. Okay, so now what is the arc length? Well, since we're dealing with such precision here, I want to carry as many. We're going to try and come back to the exact answer. You know, I probably should have wrote more decimal places, but we'll use the exact answer. But how much arc length is traversed if the pulley, so 1.25, a radian looks like about here. So maybe it's come to like here. You know, that's about 1 1/4, maybe a little bit less than that. Maybe that's like 1 1/4 radians. So how much arc length is traversed? Well, it's the simple relation S is equal to r theta, or theta r. So it's 431 pi, and what is it? Over 1080. Yeah, let's use the exact answer and then we'll round in the end. Times 9.27 inches. So this times 9.27, so 11.6 inches. Okay, through what angle to the nearest minute must the pulley be rotated to raise the weight 6 inches? So if we're raising the weight 6 inches, we're traversing 6 inches of arc length. So, and we know the radius, so theta is equal to S over R. So 6 inches over 9.27 inches. Well, and we can go ahead and let's convert this right now. This is in radians, right? So 6 divided by 9.27, that's radians, times the fact that there's 180 degrees for every pi radians. So now we're in degrees. 6 times 180 divided by 9.27 divided by pi. So 37.0846 degrees. Okay, now they want this to the nearest minute. So we know we've got 37 degrees, but how many minutes is 0.0846? Well, what we can do is, if you look at minutes and seconds from the perspective of conversion factors, I think it makes it easier. Because we can say this. We can say that we've got 0.0846 degrees times the fact that you've got 1 degree for every 60 minutes. So now we're in minutes. 0.0846 0.846 times 60, 5.076. Okay, now we could go into seconds, but the question doesn't tell us what it wants seconds, just to the nearest minute. Well, this is minutes. This is the nearest minute. Round, that's 5 minutes.